Alright, hello everyone. So this is gonna be a really short video. And actually, unfortunately, all that I wrote about the differential amplifier in the last video, all that got erased because my laptop shut down after the recording. At least that was okay. The recording was okay. But anyways, I wrote the summary of all this. So what I'll get to this topic in just in a bit, but before that I'll just go through this. So our differential amplifier, we this was the structure, this was the circuit, this was the formula for the output, where for the general case. Okay, you could say, a lot of people would say the ideal case, when if you have, if both of your supply signals are equal, your output has to be zero. In that case, we saw that the ratio of R1 and R2 has to be equal to the ratio of R3 and R4 here. All right, and the formula becomes this one. Okay, this one, V output equals R2 by R1 multiplied by a factor of V2 minus V1. All right, so that's, you could say, the ideal differential amplifier. All right, so what we're gonna see now is actually, so this was the ideal one, was a special case of this one, right? The ideal one was a special case of the general differential amplifier. All right, and today what we're gonna see, this amplifier called a subtractor. This is a general case. This is a general case of the ideal one. This is a general case of the ideal differential amplifier. And what we're trying to do with this one, okay, our goal is, okay, all right. So we have the output equals some gain, okay, or some amplification multiplied by V2 minus V1. All right, but what if we just want the difference of the resistances? What if we just want the output voltage V output to be equal to just the difference between the two supply voltages? All right, so that I am saying that I need this. Okay, I need this to be my output for this subtractor amplifier, and I think you can see why this is called subtractor. All it does is subtract, but I'll talk more about that later. So if we need this, then what do we do here? What do we do here? Well, the thing is, if I need to have V2 minus V1, okay, or it's actually, you could say it's 1 multiplied by V2 minus V1, right? So if I need this here, my R2 by R1 has to be equal to 1, right? My R2 by R1 has to be equal to 1. So let's write that down. R2 by R1, which is actually the same as I said. Wait, this is equal to 1, and I also said that R2 by R1 is is equal to R3 by R4, right? For this ideal differential amplifier, and I explained that the subtractor is a special case of this one, right? It's a special case of this one. So this needs to be equal to R3 by R4. Okay. Now, if we deal with you could say there are two equations here. We could separate this. We could deal with these. Suppose say two equations like these parts. And what we have, if we just multiply R1, on this part, we get is R2 equals R1. I think you can see where this is going. R2 is basically equal to R1, and from here what we get is R3 is oops, why is there a 4 there? That's supposed to be R4. So yeah, very silly mistake. That's R4, not 4. Okay, and from here what we get is R3 equals R4. Okay, so as a whole, and since these two are equal, okay, since these two are equal, what we have right here is, okay, so I'll use a different color for this. So your R2 needs to be equal to your R1. Okay, your R2 needs to be equal to your R1, and your R3 needs to be equal to your R4, right? So this is when you actually have a subtractor. All right, this is when you have a subtractor. So just to recap, subtractor, for subtractor, you basically, your output voltage is gonna be the difference, just the difference between V2 and V1, But V2 and V1, V2 is, it's not the non-inverting input, but it's the voltage, it's the supply associated with your non-inverting input, and V1 is the supply associated with your inverting input, with the signal. All right, so the signal associated with your inverting input. And here, if I'm just told to draw a subtractor right now, okay, what I could do, I could just refer to this. So given that this is a subtractor, R2 needs to be R1. So let's just say R1 is 10 kilo ohms. Okay, let's just say R1 equals 10 kilo ohms. Well, then this also has to be equal to 10 kilo ohms. This also has to be equal to 10 kilo ohms. This is R2, has to be equal to 10 kilo ohms. All right, and we also said that our R3 and R4 are equal, right? Our R3 and R4 are equal. So suppose say if this is, let's just say this is 20 kilo ohms. Let's just say this is 20 kilo ohms. Now this also has to be equal to 20 kilo ohms. Also interestingly, if I had set, suppose say, so this is a valid subtractor, okay, but also I guess the most easiest way to do this, you could even also set all of them to be equal, right? You could also set all of them to be equal. So here we could say that this is 10 kilo ohms. Okay, I can just set it as I want, R3 as I want. R4 needs to be the same. It also has to be 10 kilo. So this is a valid subtractor. It's actually, as you can see, I think this is very easy to come from the top of the head. If you have a subtractor, one valid way to do it is just to make all the resistances the same. Okay, and well, we'll prefer to keep it in kilo ohms. And also, the other thing is if uh, R2 and R1 are equal and R3 and R4 are equal, then you have a subtractor on hand. Okay, so it goes both ways. It goes both ways. This implies this. Oops, oh wait. This implies this. Okay, these two statements. Uh, and I'll write an and here. Okay, and this and these pair of statements imply that you have a subtractor. So this is basically all that you need to know about a subtractor. In essence, all that it does is it takes any two voltage signals and it finds the difference between them. It doesn't amplify them. It doesn't amplify anything. It just finds the difference between them. That's why it's just called the subtract. Just subtracts. All right. So that's the end of this video. I'll see you in the next one, and study smart.